Welcome back everyone to our YouTube channel. This is your tutor Namakando the scientist from Namakando Academy. So with me here I have a question under mathematical induction. So continuation of mathematical induction. Here we are taught to prove that 1 over, so these dots we have here, they represent multiplication. So 1 over 1 times 2 plus 1 over 2 plus 2 times 4 plus 1 over 3 times 4 plus, and some missing numbers there, plus the last one is equals to what you have on the right. We're proving this by mathematical induction. So we have the first case, or rather the first step. Step 1, you test for n is equals to 1. Let's see if this will work. So we only consider the part which has n for the left hand side, and this is 1 over n times n plus 1. Upon substituting with a 1 over the n, this gives us 1 over 1 times 1 plus 1, and this will give us 1 over 1 plus 1 is 2 times 1 gives us 2. So that's our left hand side. We now move on to the right hand side. This is n over n plus 1. So where there is n here, we'll replace with a 1 over n, that is 1 plus 1. This gives us 1 over 1 plus 1 is 2. Left and right are giving us the same result. We therefore conclude say case 1 holds, or rather step 1. Step 1 holds. Since this is the case, we move on to the second step, which is step 2. And this one is an assumption that n is equals to k. So mean that to obtain, or rather we write our statement and we only substitute wherever there's n with a k. So we have 1 over half, not necessarily half, 1 over 1 times 2, which is plus 1 over 2 times 4, plus 1 over 3 times 4, plus the last term, which is 1 over, here since there's n, we replace with k, then k plus 1, this is equals to k over k plus 1. Okay, so move on to the last step, which is where we test for n is equals to k plus 1. So what we now do is we obtain the right hand side of step 2, which is k over k plus 1. Then we'll say plus, come this side, because all this is expressed in terms of that, as you can see it here, upon substituting with the k over the n. So this is what we have. Then plus the last term now, which will be as a result of substituting over there's n with the k plus 1. So this gives us 1 over n here, this is k plus 1. Inside there we have k plus 1 plus 1. This is equals to, here there's n substitute with k plus 1 over k plus 1 plus 1. So we now get k over k plus 1 plus 1 over k plus 1. Multiplying with this gives us k plus 2 equal to k plus 1 over k plus 2. Alright, so what we now do next is we work with the left hand side and simplify it to be equal to the right hand side. So left hand side, okay, so find the common denominator, which is this which we have on the other fraction, since k plus 1 can go into k plus 1. Now k plus 1 into everything to give us k plus 2, which will multiply with k on top, then say plus this into everything, just give us a 1 as we multiply with the 1 there. Then k times k gives us k squared, plus k times 2 gives us 2k, then plus 1 over rho divided by k plus 1 times k plus 2. Okay, so this simplifies to, the denominator is to be maintained, Now for the numerator, this can be expressed as k squared plus k n plus 1. Can do this. Now what happens is we factorize k since it's common. This gives us k open, k plus 1. Then plus here it is 1 which is common, you have k plus 1. Everything over k plus 1 times k plus 2. So you have k plus 1 for what is inside, and what we have outside is also k plus 1 over k plus 1, k plus 2. So this k plus 1 and one of the k plus 1 on top will go. Hence we have k plus 1, k plus 2. And this is the right hand side, so it therefore conclude to say the statement holds. The statement holds for all, or rather we can use this symbol for all n in a set of positive integers. And we are done. Thank you very much.